All right. My name is San Francis. I'm from Chicago, Illinois, and I'm a sophomore CS major. And I actually learned C++ and data structures when I took it last year, so I have about 1 year experience in it. So an overview for today. Today we're going to really talk about control structures and the STL containers. And if you have any questions throughout the whole workshop, please feel free to type in the chat or just stop me. Yeah, if you don't understand anything or if you have any questions. So the first control structure we're going to be talking about are if and else statements. So if statements function this way. So it'll proceed with the word if, and then in the parentheses, there will be a condition. And then if the condition is true, then the code enclosed in the curly brackets will continue. So in this case, we see that it assigns this integer a value of 5. So if 5 is greater than 0, so that's the condition. If that condition is true, which it is, this code inside here will execute. Obviously, there's no code here because it's just for demonstration purposes, but that's how it would execute. And then else statement functions like in conjunction with the if statement. So we can see in the same example, it assigns the number to 5 again, but this time it's 5 is less than 0, but that's not true. So this code wouldn't execute, and instead it would jump to this else statement, and this code in the middle would execute. And then it would just continue as normal. So does anyone have any questions on that? Or does that make sense? If not, I'm going to move on. So a while loop is kind of like similar to the if statement, but it repeats many more times because it's a loop. So it'll have the word while and then some condition. And then while this condition is true, all the statements enclosed in the curly brackets will execute. So kind of like the if statement. The if statement executes only one time, but a while loop will continue to execute while the condition is true. So this is obviously could be a problem because if the condition will never reach, will never be false, then it could just recurse continuously, which we don't want. So you have to make sure that the condition is something that updates to where it could be false at one point. And then the for loop is another type of loop. It kind of does all the initialization and incrementing and decrementing for you, so you don't have to continuously update it in the loop, which makes it a little bit nicer, but there are situations where you'd want to use a while loop too. So it's formatted like this. So you, in this first part, you initialize a variable. So this is the starting point. So in I equals 0, so the value of I is initially 0. And then it continues to execute while I is less than 5. And then at the end of every loop, it increments by 1. That's what I++ means. So the for loop will continue to execute in the same way as the while loop until this condition is broken. So now we're going to write some example code, some example exercises using these control structures. So our first program is going to print only even numbers from 1 to 100 using a for loop. So I'm going to bring over my notepad. So we want to print even numbers. So the first thing we're going to do is we're going to include the input and output streams. That's what IOStream does. And then we're going to have our main function, and we're just going to actually write all our code in the main function for now. So we want to write a C++ program that will print only even numbers. And we want to do this using a for loop. So this is pretty simple. Do for in I is equal to 0. And then the condition will be while I is less than or equal to 100, because we want it to execute 100 times because we're printing from 1 to 100 or 0 to 100. And then we'll do an if statement to check if the number is even, because this will execute all the way from 0 to 100. So it'll do 0, 1, 2, 3, 4, all the way to 100. But obviously not all of those are even numbers. So what we want to do is if I %2 is equal to 0, if that's true, then we want to print it. So we do that using stdc out. So we'll do I, we'll do a \n, so that prints a new line. And then that will be it. And we'll do return 0, so the main function returns something. And then now to compile this code. So we're already navigated to the directory, so we do g++ -o out test.cpp because that's the file name. So we got no errors. So as you can see, printed all numbers 0 to 468 all the way to 100. So those are all even numbers. And now the next problem asks write a C++ program that will print only odd numbers from 1 to 100 while using a while loop, or using a while loop. So let's just delete all this. So we'll have a starter variable because while loops don't have that built-in initialization like for loops do. So we'll do while I is less than 101. And then we'll just print I every time, a new line. And then we'll increment, start at 1 because 0 obviously isn't an odd number. And then we'll increment I every time because you have to update it manually by 2 every time. Because if we're starting at 1 and we're incrementing by 2 every time, every number will be even, or odd, rather. So once we execute this, we can see that we got all odd numbers. And you can see that there's obviously multiple ways of doing this because I followed a different approach than I did last time. Because last time, I went through all the numbers instead of going through all the even numbers, but this time I went through only odd numbers. But we could do it a different way. We could do if I%2 does not equal 0, because that means it's an odd number. And then we print it. And we just do I++ again. So obviously that'll go through all numbers 1 through 100 instead of just only the odd numbers. But there's an if statement that'll check if it's odd. So you can do it multiple ways. And then the last one, so write a C++ program that asks the user for input, print a statement describing if this number is positive, negative, or 0. So to get input, we use stdcn. Let's write a statement telling the user to enter a number. And we'll call this number A. So to do input, so after this statement is printed, it will prompt the user to enter something. So it'll enter A, and whatever value it enters, it'll be assigned to A. And so now we want to check if it's positive, negative, or 0. So we do if A is greater than 0. So that'll obviously mean it's positive. So if that's true, then we want to print that A is positive. But if A is negative, so else if A is equal or less than 0, so that would mean it's negative. and then an else statement finally. That would mean, since I already checked if A is positive or A is negative, the last thing that we check if it's 0. So we'll say A is 0. So that should be it. And I don't think I went over this on that slide, but you can have a bunch of if and else statements like chained together like this. So there's an if statement, and there's an else statement, else if statement. So first it'll check this if statement, and then if it's not true, then it'll check this else if. And then finally, if both of those aren't true, it'll go to this. And you could just have a continuous chain like that. But only ever will one of those statements execute, no matter how long the chain is. Whichever one is first true, only that one will execute. So even if it were true that both of these things were, like if A was greater than 0 and A was less than 0 at the same time, which is obviously not possible, if those were true, only this one would still execute since it's on top. If we wanted both of them to execute, we would want separate. We do an if statement here, not an else if. But the else means they're chained together, kind of. So you can see I got an error here. Forgot to put a semicolon here at the end of the line. We'll go ahead and compile it again. Just forgot to save it. Then we'll run the code. So enter a number. It could be any positive number, let's say. We'll say 55. So it says A is positive. Let's run it again. Let's do a negative number, negative 55. A is negative. Now let's do 0. A is 0. So it works. If anyone has any questions, feel free to ask. You can unmute yourself too if you're comfortable talking. Now we're going to go over functions. Functions are a way to make code a lot more neater. It's basically a group of statements that are executed when the function is called. And they're formatted in this way. So the return type is the first thing in the function. And then the name, whatever you want to name your function. And then the input parameters. And then whatever statements that you want to execute. And this type can be void if you don't want to actually return anything from the function. And then this is just an example function that I wrote. So we're returning an integer, and we'll call it addition. And the input parameters are an integer A and an integer B. And so we want to return A plus B, so we just return A plus B. And then if we want to print this, this is an example of how you kind of call the function. So let's say in the main function we called this. So we printed out addition parenthesis 5 comma 2. So that would call this function with parameters 5 comma 2. So A would be 5 and B would be 2. And then it would return 5 plus 2, which is 7. So it would print 7. And so there's these parameters, they can be passed by value or be passed by reference. And being passed by value means the variables aren't modified, which means like outside of the function, wherever you called them, those functions will still equal whatever you first define them as. But if you pass them by a reference, the function can actually change those variables. So let's say we pass, let's say we modified this function to pass A in, and then we subtracted A, and that's all we did. We didn't return anything. We just did A minus minus. And let's say A was equal to 5 initially. If it was passed by value, A would still be 5 at the end of the function call. But if it was passed by reference, A would be equal to 4. And we'll talk a little bit more about that later, but you can see I actually wrote it here. So yeah. And this is how to pass it by reference versus by value if you have this ampersand here. So now we're going to go back to coding again. So we're going to write a function that has an input of floating point numbers A and B, and we're going to return true if A is strictly greater than B. We're going to test this in the main function. So to do this, we just delete all this old stuff. So we want to return true. So if we're returning true or false, the function will be Boolean, which Boolean means it returns true or false. And we'll call that function function1, and it needs to take parameters of floating point numbers, because that's what it said in the instructions. So floating point numbers a and b, so there's 2 parameters. So that's just kind of a skeletal of our function. And so let's go back to here in the main function. So let's actually get those from the command line. So let's do stdcout, enter a value for a, and then we'll request input from the user. So, and we'll assign that to floating point numbers a, comma b. So that's a way to initialize 2 numbers at once. And then we'll do the same thing for b. Just copy and paste that. And then now we can call this function right here. We'll actually print the result, so we can see if it's working properly. So we'll call it here function _1, and we'll do a, comma b. So here it's asking the user for input for a and b, and then here it actually calls the function that we haven't defined yet, and then it's outputted. So it asks to return true if a is strictly greater than b. So it's pretty simple. We could do this, return a greater than b, because this conditional statement actually returns true or false. So it would return true or false, obviously, but a little bit more intuitive way of doing it would be if a is greater than b. Then we could return true, and then if it's not true, we could return false. So if it's true, then it returns, and then the function ends. This doesn't happen. But if it's not true, then obviously this only happens. So now we can go ahead and test our function. Oops, forgot a parenthesis. So we tested it, we see we got no errors. So ask for a value of a, we'll say 5, and we'll say 3 or 2. And you see it outputs 1. I don't know if you can see that, it's kind of small, but it outputs 1. And so basically, it never actually prints true or false unless you tell it to, but it'll print 1 or 0. So if it's false, instead it'll print 0. So let's say a is 4, 5 is 52, so that's obviously greater, so it prints 0, so it's false that time. Pretty cool. And then now we're going to write a function that, given 2 angles of a triangle, finds the 3rd angle. So let's change this up. Delete this. We can actually keep this because we can just ask the user for input in the same way. But let's make a new function. It's called full out triangles because we want it to return the 3rd angle. And the parameters it's going to take are 2 floating point numbers. So float A, float B. I'm just going to change this so that we actually print what the function is actually called, not the old one. And then we're just going to return 180 because all the angles in the triangle are added up to 180. So 180 minus A minus B. So that should work. So now we're going to test the function. We got no errors. So let's say one angle is equal to 40, the other one's equal to 30. then the last angle is equal to 110. So those are functions. Now we're going to go over containers, which is a pretty important part of programming. So a container, in the simplest way, is an object that like stores other objects, and there's multiple types of containers, especially in C++. So an example is a sequence container, and sequence containers store elements that can be accessed sequentially, so it stores the order that they're actually defined in. An example of this are arrays, vectors, and lists. And then there's also associative containers. So associative containers store elements non-sequentially. So instead, it actually automatically sorts the containers every time a new element is added. And a benefit of this is the access time for objects are much faster. And examples of these are sets, maps, multisets, and multimaps. And we'll go over these later. And then the last type of associated, or one more type, actually, there's container adapters too. But unordered associative containers are unsorted, but they can be quickly searched. So an example of this are unordered sets, unordered maps, and so on and so on. And then there's also container adapters, which are sequence containers, but they're a little bit modified. So an example is stack or queue, and also priority queues. So let's go over the most basic form first, arrays. So an array is a series of elements that can be referenced by their individual indices. But one disadvantage of arrays is that the size cannot change. So once you define it in the beginning, you can't change it at all. And to get the number of elements in the array, you're going to have to perform this operation. So you're going to do size of whatever the array is divided by size of, and then the first index. And this is because C-style arrays don't have their own defined size function, but that's basically what everything does in the background. And then to access an element at index I, this is how you're going to reference it. So the array name, and then in a bracket, then the index you want to access. So now we're going to do another exercise where we're actually programming. So write a C++ program that creates an array of numbers 1 through 10 and then prints the elements in the array. Let's go back here. All right, let's get rid of this function. So let's call this array A, and let's set it to size 10 because we're printing numbers 1 through 10. And so that's how you define the array. So it's an integer array, and this is the name, and then that's the size. And then these are the contents in the array and the order in which they're stored. So we're just going to do numbers 1 through 10. And then we're going to actually go ahead and print this. So we're going to do a for loop, for. And since array does not have a built-in size function, let's define the size here just to make it a little bit easier. So we have to do size of A divided by size of A of 0 and then you increment I. So this will be a loop that goes through all numbers starting at 0, and then the size of the array, which is 10. So numbers 1 through 10. And then we're going to print the element of the array. So I'll do this. And then we'll just print a new line. And now we can run this. So we get no errors. And you see here it prints numbers 1 through 10. If anyone has any questions, please feel free to say something in the chat. So the next problem asks to write a function that finds the maximum and minimum values in an array. We don't have to write a function because we've already been over that, but we could use the same array. So to do this, we just have to keep track of the maximum number. So let's say the max is 0 initially. And we want to test if at any point the max changes. So what this does is so the loop goes through everything, and then if the array element is greater than the current max, then the max will become the greater array element. So once that loops through the whole way through, it'll find the max. So in this case, it should be 10. And then we can just print that. And we'll save that and run that. No errors. Oops. Messed up the operator. So you see we get the maximum number in the array, which is 10. Write a function that prints the reverse of an array. We don't really have to do this because it's kind of tedious at this point, but if you have any questions about arrays, you can type it in the chat. Now we're going to go over iterators. Iterators provide a simple way of traversing containers because not all containers can be just traversed sequentially, so you can't use like a for loop, just starting from I and then a dot size function. Not all containers have that, so a better way to do it is through iterators. And you can see an example of iterating through a vector here with an iterator. So you see there's the begin function that iterators have built in. Most containers have this. So the vector one, so it calls it here, obviously, with this vector v. So we declare this iterator here, and then here in this loop, we start at this value, so we start at the beginning, and then while the iterator does not equal the end of the vector, then you increment the iterator, and then here we're just printing the contents of the array. And we do this by dereferencing the iterator, which sounds pretty confusing because we haven't talked about pointers or anything. But for now, just know that you can't return like an iterator type, so you have to dereference it, which we do so by putting an asterisk in front of it. But yeah, we'll talk about more of that later. So let's talk about vectors. Vectors are C++'s implementation of dynamic arrays. And so some benefits of vectors over regular arrays is that it's automatically resized when an element is inserted or removed, which means that the size that you defined in the beginning when you declare the array can be changed, which is a big help for many things. And so these can be traversed through iterators, but they can also be traversed in the way that we traversed the standard arrays, because vectors do have a dot size function. And so this is kind of confusing format, but if you want to call functions on a vector, this is how you would do it. We would do the vector name, and then the function name, and then what parameters you need to do inside these parentheses. So for example, we wanted to call the pushback function, which just inserts an element at the end of the array. We would do the vector name and then the function name, which is pushback, so v_name dot pushback, and then whatever element inside these parameters that we want to insert. And the insert function is a different type of insertion that just inserts an element at a specified index. So you include that in the parameters. And then the size function that I talked about before just returns the size of the vector, which can be really helpful for like printing or traversing the array. And then I obviously can't go through all the functions of vector, but you can easily find them online. And this is just a link that shows you like the many ways you can initialize a vector. So you could do this, you could declare the vector here and then insert each element individually. You can create a vector of size n with all elements initially equaling 10. You can initialize a vector in the same way we did before the array, using these curly brackets. And then, yeah, so you can just see there's a lot of different ways to do it, and none of them are right or wrong, or really necessarily better. It's just depending on the situation. So now we're going to talk about lists. Lists are C++'s implementation of a doubly linked list. And so another benefit compared to arrays is that they are resizable, and they can be traversed using iterators again. And so they have a pushback function that adds an element to the end of the list. But they also have a push front function that adds an element to the front of the list. And then they have a size function, and then obviously a ton more functions. And it's pretty similar to initializing a vector. The one difference big difference between vectors and lists is unlike vectors that can be just referenced by their indice, you can't really do that with a list. And we'll talk more about like performance issues and why one container may be better than another in like a certain scenario, but for now, I think it's better to just discuss all of them. So we're going to kind of write the same functions as we did before, except using input vectors and instead using vectors and lists than arrays, just because it's easier to learn that way, in my opinion, if you're comparing it to all the other things. So we're going to write a C++ program that finds the largest number in an input vector. Just delete all this so we can start over. So right off the bat, what you have to do is you have to include the vector library, so the program knows, or the compiler knows that you're using the vector library. Otherwise, it won't compile. And you also have to use this std scope because we're not using namespace std. So let's make a vector of integers and we'll call it a. And we wanted to find the largest number. So let's just fill this with random values. Put the largest number in the middle somewhere. And then now we can obviously traverse this either using an iterator or we could just traverse it like by dereferencing like the indices. So we could do a.size and then I++. So this will go through every single element in the vector. So it starts at 0 and then goes all the way to the length of the vector. So we want to find the largest number. So let's keep track of each biggest number using a temporary variable. So we'll call that 0. And so if this temporary variable is less than the current index, that means we want to make that the number because that's going to be the largest number. So you can see it's pretty similar to what we did with the array. We're just going to print this now. And now we can go ahead and run that. So we compile it and then run it. And we see we get 433 as the largest number in the vector. And then the next program we're going to write is counting the number of occurrences of an element k in an input list. So we're going to make a list. We're just going to delete all of this stuff. And like before, instead of vector, we have to include the list. We have to do std list of integers. So the type goes in these angle brackets. And then the name we'll call L1. And then we can define the list like this. So we can just insert the elements one by one. So we'll do 1. We'll just keep copying and pasting this. So again, just inserting all the elements. Do 1, 2, 3, 4. Oops. So, and let's just say in this scenario, our k for the function, which k, so we're counting the number of occurrences that an element k in the input list occurs. So let's say k is equal to 1 in this scenario. Just assume that. So then when we traverse the list, let's use an iterator this time. Oops. So we have to define the iterator first. So it's of type list. Oops. And we'll call it ITR. So now we'll do a for loop to traverse the list using this iterator. So we'll start at the beginning using the begin function, and then while it does not equal to end, and then we'll increment the iterator. And now we want to check the number of occurrences that k has. So we'll have a counting variable. We'll start it at 0. And then if, so again, to dereference the iterator, we have to use that asterisk. So if that is equal to 1, because that's our value of k in this situation, we're going to increment our count. And so it'll go through the whole loop. And then finally, after the loop executes, we want to print our count. So we'll go ahead and compile that. And we can see that it prints 2 because 1 occurs twice. Now we're going to talk about sets. So some unique aspects about sets are that all the elements are unique. So there can't be any duplicates, and elements cannot be modified. But however, if you want to get past this, you can remove and insert elements. And I talked about it before. There's also things called multisets and unordered sets, and they're a little bit different. So multisets are different because they allow duplicate keys. But unordered sets are the same as normal sets in that they don't have duplicate keys, but instead they're not sorted. But sets and multisets are similar in that they're sorted, so kind of confusing. So some of them are sorted, some of them allow duplicate keys, some of them don't. But yeah, it's the basic notion of it. And then to declare a set, whatever one it is, you just put set and then in angle brackets the type of set you want, and then the name of the set. And then maps. Maps are pretty similar, or kind of similar to sets. But a map is the key difference between a map and a set is that map has a key and a value. So every element is composed of a pair, essentially. So a pair of a key and a value. And in standard maps, duplicate keys are allowed or not allowed. But you can have as many duplicate values as you want. So an example use is when you have pairs of elements that are associated with each other. So when you want to like store two elements specifically with each other at all times. And elements are automatically sorted in maps. And then all the rules, as we talked about before, about sorting and not sorting, they're all similar to the sets with like multi-maps and unordered maps. So multi-map is sorted and allows duplicate keys. Unordered map is unsorted and does not allow duplicate keys. And then to declare a map, you do it in the same way, except this time you have two types, and these types can be different too. So you can have like an integer here and a string here if you want it. But yeah. And then this is kind of a nice illustration that I think demonstrates pretty well the differences between all the containers. So an array and a vector kind of looks like this. So it has these indices. So it's kind of like a table. And they're all ordered in the way that they're inserted. Whereas sets, they're kind of just floating in place. So they're unordered. And then dictionary, which is another word for map. It has these keys that are linked to certain values. So let's see that they're associated with each other. So now I'm just going to demonstrate how they actually work. So we're just going to make a set with multiple duplicate values and then print this set just to observe like how it works if we provide duplicates, which we know that it does not allow for duplicate values. So I just want to kind of show you like what will actually happen if you do it. So we're going to include the set library. And then let's declare a set. Let's make it of integers. We'll call it S1. And then we'll just insert a bunch of elements into this. So let's insert 10. And then let's insert 10 again and see what it does. And let's insert 2. Let's insert 2 again. And then let's just insert unique number. And then now let's just iterate through this and print what's in the set. So we're going to make an iterator, a set iterator, plus itr. Then we're going to loop through every element in the set in the same way as we did for the list. So we're going to set this equal to the beginning of the set, and then it's going to continue until the iterator will equal the end of the set. And then we increment the iterator here. And then we're just printing this. So we dereference the iterator. Let's just add a new line so it looks nicer. That should be it. So we're just printing this set and seeing what it does with the duplicate values. So you can see it prints 2, 10, and then 33. And what's interesting is it just gets rid of the 10, even though we inserted it twice, and same thing with the 2. Another thing that's interesting is that it's not printed in the order that it was inserted. So you can see that it is indeed unordered. And instead it's printed in sorted from least to greatest. And then now we're going to make a map with keys as people and people as values. Another thing just to test like the duplicate value thing, but with maps this time. So let's include the maps, the map library. Let's declare a map, and we want it to do people and locations. So those are both strings in this case, just for sake of simplicity. And we'll call it m1, m1.insert. So now let's actually insert all those values. And then because of the way the map insertion works, you actually have to insert them as a pair, which may be kind of confusing, but this is how you, so you're going to make a pair object first, and it's going to be of string and string, because those are values of your map. And then this is how you construct a pair object, and then that's what you're going to actually insert. So let's insert me. Let's say I'm from Glenview. And then let's insert a bunch of other people. Let's try me with a duplicate key, but a different value. And then let's try someone with the same value, but a different key, and let's see what it prints. Oops, I forgot to print it. So now we're gonna have to make a map iterator. So it's a map of string, and then string. So iterator, we call it ITR, and then we'll loop through from the beginning with the map to the end. So m1.begin all the way to the end. And we'll increment the iterator. And then it's a little bit different to print the iterator for maps, because there's obviously a key and a value. So what you're going to have to do is you have to indicate that you want to print the first object, and you do this by with an arrow, so a hyphen and the angle bracket. So that indicates that you want to print the first one, and let's include a space in between. And then let's print this. Let's use a comma here, and let's print the second object. And then let's just print a new line every time as well. That should work. So let's go ahead and compile our code. See, we get an error. Oops, I didn't put semicolon. So it compiles. Let's run it. And this is our output. So we see we inserted twice. I did a value of send Glenview and send Chicago. But it only printed on the screen send Glenview. And this is because there's a duplicate key and it can't print both of those things twice, even though the values are different. But you can see we have duplicate values here. So Zoe Glenview works still. So that's actually all I have for today. Next time, or in the future, we could talk about multi-dimensional containers, pointers, dynamic memory, classes, pointer arithmetic, special member functions, and a lot more.